like this. So we talked about how to find them algebraically when they're in the format like y equals some number in front of x and then the constant. These look different because x and y are on the same side, but how we solve them is not really different. We're still putting in 0 for x or for y to solve for the other. Now we just have to solve for both. Whereas in the other format, we didn't need to solve for the y-intercept. So let's do a few of these together. So for, yes. Yes. So for number 1, so we're going to do this one fully, and you'll see what I mean by that here in a second. And then as we move on to the others, you may not need to do like every single step that we do in number 1. So just to refresh all of our memories, if we're looking for the x-intercept, we're going to put 0 in for y. If we're looking for the y-intercept, we're putting 0 in for x. So if I'm looking for the x-intercept of number 1, I'm going to put the 0 in for y. And then I'm going to solve. Well, this is going to become 0. So really, I can just set 8x equal to 24 and solve. So my x-intercept would be at 3, 0. I'm going to do the exact same thing for y, except now the 0 is going to go in for x. And solve. So this would become 0. I could really just set those equal to one another and solve. By dividing both sides by 3 to get 8. So that y-intercept would be at 0, 8. So now that we kind of know that anytime we're solving for x or for y, we're putting 0 in, you could really think about this as, I don't really need to show these first 2 parts. As long as you know that's what you're doing, you could kind of skip those 2 parts and move to this last step. Take whatever term it is, cover up the other one if you need to, set it equal to the end. So 4x equals 8. In my mind, I put 0 in for y. It became 0, so it disappeared. I just didn't write that part. Sometimes you'll have terms that don't have numbers in front or coefficients, which means when I set that term equal to whatever the end result is, there's nothing I need to solve for. That is my y-intercept or x-intercept, whatever it is. So yes, there is an imaginary 1 in front of y, but dividing both sides by 1 wouldn't change anything. So in my mind, I put 0 in, for x, that became 0, it disappeared. I just didn't write all that. Anybody have any questions on those? So we're going to skip down to 5 and 6 because these are special case equations. Before we actually do them, I'm going to graph them just so you can see what they look like. One said x equals -1, y equals 1. We'll do one at a time. So this red line represents x equals -1. Anytime you have just x equals some number or y equals some number, it's not going to be like our normal equations. You're missing one of the variables. Usually these will either be straight vertical or straight horizontal. We'll get more into that when we get into slope graphing and writing these equations. But for x and y-intercept purposes, if I have a vertical line at x equals -1, what is my x-intercept? -1. It's like a trick question because they give you the answers, so there's nothing to really solve. They just need you to know that that one has an x-intercept at -1. Well, what would the y-intercept be?
0.
Does it cross at 0? Does it cross the y-axis at all? But we can't say it's 0. So if we said it was 0, that means it would cross at 0. This one doesn't have 1 at all, so put none, doesn't apply, nothing, whatever, insert word you want. I'm going to draw that on here just so you kind of remember that's what it is. That would be your x-intercept. Your y-intercept would be does not have one at all. Now, if this line happened to fall on the y-axis, it would have infinitely many y-intercepts because it would always be crossing the y-axis everywhere. But you wouldn't get one like that. So then in that same mindset, if I have this graph at y equals 5, that one's going to look like this. What is my x-intercept for that one? None. It does not cross the x-axis at all. And then my y-intercept? 5. So again, if this line were at y equals 0, it would cross all of your x's, infinitely many. You'd have infinitely many solutions, but that would not be one of these type of questions. I am going to give you about 10, maybe a little bit more minutes to work through 3, 4, 7 to 10. Go back and do the 3 we didn't do in the algebra by hand if you didn't do those. And then we'll go through all of those here in a bit. I'll be walking around. If you have questions or just want to check your answer, let me know. You can work together on this if you so choose. But you have this time to work. So the writing on this is small, so I'm just going to read it out loud. You can check your work with it. But on this page, number 2, the x-intercept was -1. Y-intercept was 2. So if you didn't try these, I would say you could write the answers down, but still try them. That way you get practice. Number 3, the x and y-intercept were both 7. And number 5, the x-intercept was -4, y-intercept was 2. Do you have questions on any of those? I know the work is up there, but I don't know if you can see it, so if we need to go over any of them, let me know. We need to go back to that. Please let me know. I will go back. For number 3, x-intercept was 12, y-intercept was -8. Number 4, x-intercept was 56, y-intercept was 8. For 7, x-intercept was -1, y-intercept was -10. 8, x-intercept was -3, y-intercept was +7. 9, x-intercept was -4, y-intercept was -8. And 10, you either got a fraction or a decimal. 20, -25/4 or -6.25 for the x-intercept, and 5 for the y-intercept. You have any questions on any of those? Need to go over any of those? The biggest thing with these is making sure your 0 is in the right place when you list them as an ordered pair, and then as like this is really more of a minor issue, making sure when you're dividing correctly, bringing down negatives, things like that. I'm going to go back to the graphing page. I don't have my computer calculator yet, but if you were to, one, you're not going to get questions like this on the quiz or test, but if you had to practice or if you wanted to check yourself, this would be a good way to do it. If you had the calculator, go into like the y equals, put in your equation, look at the graph, find your x and y intercepts that way. If you had Desmos kind of gives you those, so that would be easier and a nice way to see it. So I'm going to put in like number 7 into Desmos, just so you can see it. Someone read that one off for me. It was like x to the 3rd. So it's going to graph whatever mess you put in there, and if it lies on the x or y axis, you'll see points. So you can click on those points and see exactly what your x and y intercepts are without really doing too much work. So anytime you have a problem and maybe aren't sure, did I do this correctly? Are my x and y intercepts correct? Put it in the Desmos, put it in your calculator, see what those are, see if they match. If they match, then you did that right. So that section we're not really going to do, but you could put them in Desmos, put them in your calculator, and see what those are. So I know I mentioned this last lesson, I just want to mention it again. You have one delta math on intercepts, both from an equation and a graph, due Monday. You have 2 Khan Academies. One is intercepts from a graph. One is intercepts from an equation. They're both due by end of day today.
End of day like today, like midnight.
11:50. get you done. But remember, you can do them over the weekend as well. You have about 14 minutes, 15 minutes left of class. You could get all of that done right now, then you don't have any homework for me over the weekend. But you have this time to work.